Welcome to Nature Walk, the podcast where we explore the wonders of the natural world and uncover the fascinating stories that surround us. I'm your host, David, and I'm excited to share with you today's tale of incredible adaptation and intelligence in the animal kingdom. Imagine being able to navigate your surroundings with ease, despite having poor eyesight and thick skin that makes it difficult to feel even the slightest touch. This is the reality for elephants, but they've developed an extraordinary solution to compensate for these limitations. Their trunks are equipped with over 1,000 highly sensitive whiskers that provide them with a strong sense of touch, allowing them to manipulate objects with precision and care. But what makes these whiskers so special? Researchers from the Max Planck Institute for Intelligent Systems, Humboldt University of Berlin, and the University of Stuttgart in Germany set out to investigate the unique properties of elephant trunk whiskers. Using micro-CT scanning, they discovered that these whiskers are unlike those found on other animals, such as mice and rats. Instead of being tapered and uniformly stiff, elephant whiskers are thick and blade-like, with a hollow base and internal channels that make them more resistant to impact. The team also found that the whiskers exhibit a remarkable stiffness gradient, transitioning from a stiff base to a soft, rubber-like tip. This functional gradient allows elephants to determine precisely where an object is coming into contact along each whisker, enabling them to pick up delicate objects without breaking them. It's a truly remarkable example of embodied intelligence, where the structure and properties of the whiskers themselves provide the necessary information for the elephant to navigate its environment. To better understand how this stiffness gradient affects touch sensing, the researchers created a 3D printed whisker wand with a stiff base and soft tip. By testing this wand, they were able to experience firsthand how the changing stiffness along the whisker would affect the sense of touch. The results were striking, with the team able to pinpoint exactly where the wand was making contact simply by feeling the difference in sensation between the stiff and soft sections. This incredible adaptability has significant implications for the development of robotics and other intelligent systems. By incorporating similar stiffness gradients into artificial sensors, robots could gain a more precise sense of touch, allowing them to interact with their environment in a more nuanced and effective way. We'll be right back with more fascinating stories from the natural world on Nature Walk. Welcome back to Nature Walk, where we're exploring the wonders of the natural world and delving into the latest discoveries that are shaping our understanding of the planet. Today, we've got a fascinating tale that takes us back in time, to an era when the first land vertebrates were making their mark on Earth. Imagine a creature about the size of a football, with a stout body and teeth adapted for eating plants, a true pioneer in the world of herbivory. Scientists have recently uncovered a 37-million-year-old fossil, which they've named Tyrannorata herberti. This remarkable find is providing valuable insights into the evolution of plant-eating animals on land. The discovery was made by a team of researchers who were studying fossils from a site in what is now North America. As they carefully examined the ancient remains, they realized that they had stumbled upon something truly significant, one of the earliest known land vertebrates with teeth specifically designed for consuming plants. This chunky, squat creature would have roamed the Earth during the Paleozoic era, a time when the planet was still in its formative stages. The environment was vastly different from what we see today, with lush forests and vast swamps covering much of the land. It's likely that Tyrannorata herberti played a crucial role in shaping these early ecosystems, helping to disperse seeds and nutrients through its plant-eating activities. The discovery of this ancient herbivore is not only shedding light on the evolution of plant-eating animals, but also highlighting the importance of preserving our natural heritage. As we continue to face the challenges of climate change, habitat destruction, and species extinction, it's more important than ever that we learn from the past and work towards a more sustainable future. The story of Tyrannorata herberti serves as a reminder of the incredible diversity of life on Earth and the complex relationships between species and their environments. As we explore the natural world, we're constantly reminded of the awe-inspiring beauty and complexity of the planet we call home. Welcome back to Nature Walk. As we conclude our journey through the fascinating realm of science and nature, I'd like to take you on a captivating exploration of the human brain and its remarkable connection to exercise. You might be wondering, what drives our endurance when engaging in physical activity? Is it solely dependent on the strength of our muscles or the health of our cardiovascular system? Well, recent research suggests that the answer lies, at least in part, within the intricate workings of our brain. Scientists have long understood that regular exercise can lead to changes in the brain, but a groundbreaking study has revealed that these changes are not just secondary effects. Instead, they play a crucial role in coordinating our body's response to physical activity. The research, led by Nicholas Betley at the University of Pennsylvania, focused on a specific group of neurons in the ventromedial hypothalamus, a region known for its involvement in brain development and metabolism. By monitoring neuronal activity in mice before, during, and after exercise, the team discovered that these neurons, equipped with a receptor called SF1, become increasingly active as the animals run. This activation grows over time, much like how our muscles build strength with consistent exercise. But what's truly remarkable is that when these neurons were inhibited using optogenetics, the mice showed significantly reduced endurance. They were unable to run as far as their counterparts, whose neurons were left intact. The role of these neurons seems to be linked to fuel utilization during endurance activities. When they're active, they help the body use fat as a primary source of energy, delaying the depletion of carbohydrate stores and thus prolonging our ability to exercise. Moreover, these neurons release substances that aid in muscle recovery by increasing blood sugar levels and replenishing energy stores. While this research is promising, with potential implications for developing interventions that could enhance endurance, especially in individuals who struggle with physical activity due to age or health conditions, there are also challenges to consider. The primary concern is whether these findings translate to humans, as well as the potential side effects of stimulating these neurons, such as dangerous drops in blood sugar levels. As we reflect on this study and its implications for our understanding of exercise in the brain, it's clear that while activating these specific neurons could potentially increase endurance, it's just one piece of the puzzle. The benefits of exercise are vast and multifaceted, improving not only our physical health, but also our mental well-being. That's all for today's Nature Walk. Remember to like, share, and subscribe, and until next time, keep exploring your natural world.